All right, we'll start out day number 3 with example 7. We want to integrate sine of x over x from 0 to 1. Now, there'd be no way to do this normally except to type it into a calculator, but as you can see, we don't want to use calculators here. And so instead, we're going to use power series. So we'll start off with the memorized power series for sine of x. And then we'll go ahead and we'll divide each term by x to give us sine of x over x. As you can see, all the x's simply come down by 1 power. And now we want to integrate it from 0 to 1. Do the same thing on the other side. And this answer is going to come out to be, well, unfortunately, we're integrating something that's infinite. But remember, we only have to go as far as we need to get an error of less than 1/10,000. So let's integrate first. We have to do that, of course. The integral of 1 is x minus. All right, let's see, x squared, that's going to be x to the third, up by a power. Divide by the new power, so divide by 3, but there's a 3 factorial there already. Okay, plus, same thing here, up by a power, x to the 5th. Divide by the new power 5, but there's a 5 factorial. I think you can start to see the pattern. We'll go one more. Hopefully we won't actually need to use the 7th power, but just in case, we'll have it here. All right, and we're going to integrate that, or I should say we're going to evaluate it. We've already integrated it from 0 to 1. And since all the terms have x's in it, we don't have to try the 0 in, simply have to try the 1 in. Okay, so here goes. Obviously, that's a 1. Minus. These are all going to be 1s up top, so that's going to be pretty simple. Let's see, down here, 3 times 3 factorial. That's 3 times 6. That's going to be 18. So minus 1/18. Again, we have to be within 1/10,000, so we're still a ways off yet. So let's forge ahead. Plus 1 over 5 times 5 factorial. 5 factorial is 120. Multiply that by 5. That's going to be 600. Which, of course, is nowhere near 10,000, so we move on. Minus 1 over, okay, 7 factorial is 5040, 5,040. If you multiply that by the 7 that's in front, you're going to get 35,280. And I think you could probably tell that even if you had multiplied by 2 instead of 7, you'd already be safely past the 10,000 in the denominator. So we're good. So we don't need that last term. We only need to add the first 3 together. These ones right here. And we'll need a common denominator, and I would suggest that common denominator to be 1,800. Let's bring this down 1. Of course, will be 1,800 over 1,800. Minus, we throw a couple zeros on here, you can see that that's 100 over 1,800. And finally, multiplying by 3/3, it's going to be 3 over 1,800. Putting this all together gives us a final answer of 1703/1800ths. Again, we can check it on the calculator. I think that's always a good move. Let's see how close we really were. All right, I've got the original typed in. I may have gone a little extra crazy with the parentheses, but better safe than sorry. All right, that comes out to 0.9461. And our answer that we got of 1703/1800ths, let's just make sure that it's believable. Oh, heck yeah. It's accurate to the first 4 places. Certainly within 1/10,000th. All right, fantastic. All right, number 8 will be the last one. It's a free response style question, so it's going to come in 3 parts, A, B, and C. 8A wants us to write the first 3 non-zero terms of the Taylor series for cosine squared of x about x equals 0. Okay, so this is going to be Maclaurin. We don't have anything memorized for cosine squared. We do have the memorized formula for cosine. So we're going to have to derive it. And this is how we do it. We use the half-angle formulas from pre-calc. Hopefully this is a formula that you know and love and you recognize. If not, maybe want to go back and review your trig identities. The arguments, which in this case are the x over 2 and the x that's inside, you may notice that this is always exactly twice as big as the one out here. That's true all the time. So they can be anything that you want. Right now they're x over 2 and x. I'm going to double them. I want to make this an x out here, forcing this one to become a 2x, which is completely fine. So I will do that now. And now I want to square both sides. So the left-hand side will become cosine squared of x. The right-hand side, when I square it, the square and the square root are inverses of each other, so they will cancel out. And I don't need the plus minus anymore, because even if it was negative, I just squared it. And so that leaves us with cosine squared of x equals 1/2. I'm going to kind of go like this. Plus 1/2 cosine 2x. Now at least the cosine is linear instead of squared, and that way we can use memorized formulas. So that is great. We're going to do that right now. This 1/2 can simply just drop down. The next 1/2 I'm going to keep out front, and we're going to take the cosine of 2x and put it in the parentheses. And of course, cosine of 2x is a memorized formula. Well, at least cosine of x is a memorized formula. Let's do that formula, and then I'll change the x's to 2x's later. Okay, cosine of x, I realize it's a 2x, but cosine of x would be 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial minus, the signs always alternate. And notice that all the powers are always the even powers with cosine. And that'll go on indefinitely. Okay, the blue is the memorized formula for cosine of x. I didn't write the x's in because they're really 2x's, so we're going to put those in instead. And now we just need to simplify some things to get down to the first 3 non-zero terms, which is what we're asked to do. Here we have a 1/2 plus another 1/2 that's going to happen through distributive property, so that's 1. So we have 1 minus right there. Oh boy, okay. A little mental math. 2x times 2x, that's 4x squared over this 2 times 2 factorial. That's going to be over 4. And eventually those 4's will cancel in our next step. Okay, plus, all right, 2x to the 4th. That's 2 to the 4th is 16. So 16x to the 4th. 4 factorial is 24, but we also have a times 2, so that's going to be 48. I don't need the 6th power because it says find the first 3 non-zero terms, and none of those are 0, thankfully. I just need to simplify a bit. So here we can cancel the 4's out, and 16 and 48 are beautifully going to knock down to 1/3. And so from my final answer for cosine squared of x, the 3rd degree Taylor series, if you will, or Maclaurin, is going to be 1 minus x squared plus 1/3 x to the 4th. And that is the correct answer. That's one way to do this. There is a second way, and I do want to show you both ways because I think there's some value in this. A lot of students are a little freaked out by what I just did because they don't have the pre-calc memorized, and that's all right. That happens, and it's a lot to go through. So maybe the second way you'll like a little better. To be honest, the second way sometimes can be pretty terrible, especially when you're asked for more than 3 terms. If you're asked for, 5 or 6 terms, you don't want any part of this next way. Okay, but let me save the answer that we know is correct, and I'll show you a plan B here. And of course, cosine squared, many of you probably thought this right away. They're like, why isn't he just using cosine times cosine? Those are both linears. And you're right. So let's try that. And of course, each one of those would be the memorized formula that we know. Now keep in mind that these parentheses really do go on forever. I chopped it at x to the 6th because I was hopeful I wouldn't have to go any farther, especially since we're only being asked for the first 3 non-zero terms. So let's FOIL this out. And again, you can imagine how awful it will be to FOIL out 2 things that both go on forever, which is why this second method can be limited at times. But let's go for it. 1 times 1, of course, is 1. Minus 1/2 x squared. All right, that looks good. Plus 1/24, because again, this is 24 down there. X to the 4th. You know what? I'm not going to try this I'm going to leave the x to the 6th out. I'm going to do that because I already know what the answer is, and it doesn't have anything past 4th powers in. Normally, I wouldn't be so brazen, but here I will be. All right, let's try the next term, which is this negative 1/2 x squared. We're going to send it through. All right, so the first one will be negative 1/2 x squared. I'm going to line that up with the other x squareds. Let's see, negative times negative will be positive. It's going to be something x to the 4th. Let's see what the something is. We have a 1/2 and a 1/2. That's 1/4 x to the 4th. I don't have to go any further because if I did, that would be x to the 6th, and I'm not going to need it. All right, one more step. We need this because that's going to be more 4th powers. This is 1/24 x to the 4th times 1, so it's going to be another 1/24 x to the 4th. I don't need to do this dotted step because, again, it's going to be to the 8th power. That's too big. I don't need it. And you can see when we combine the like terms, the 1 is by itself, which is okay because that matches the answer. Minus 1 full x squared, which makes sense. And this must add up to 1/3 x to the 4th. Let's see if it does. We have 1/24 and 1/24. That's 2/24. That's 1/12. Plus 1/4. 1/4, if I was to convert that to 12ths, would be 3/12. And 1/12 plus 3/12 is 4/12, which is 1/3. So yes, both ways do work. So the answer is 1 minus x squared plus 1/3 x to the 4th. All right, that's part A, the first 3 non-zero terms of cosine squared. Okay, 8b, we're going to let f of x be the cosine squared that we just had, plus an additional cosine. And we're going to take the first 3 non-zero terms of that. This actually shouldn't be hard at all because cosine squared was the answer to 8a, so I'm just going to copy, cut, and paste that to this screen. Okay, so there's the cosine squared. I only listed the first 3 terms because that's all I figured out in part 8a. I'm hoping I don't need any more than those. We do need the first 3 non-zero terms now, but hopefully nothing's going to cancel out when we hitch on this extra cosine of x, which of course is a memorized formula, at least hopefully it is. And it looks like we've had some pretty good fortune. Nothing's going to cancel, so we don't have to go any farther than that. I'm going to figure out what f of x is right now. Again, this cosine squared plus cosine has got an alias. It's also called f of x. Okay, they're the same thing. So, all right, what's it equal to? Well, 1 plus 1, of course, is 2. We have 2 negatives added together. That's going to be negative. This is minus 1x squared. This is minus 1/2 x squared. That's going to be minus 1.5 or 3/2 x squared. Then finally, the fourth powers, we have 1/3, and we have 1 over 4 factorial. That's 1/24. Let's see what that makes. 1/3 plus 1/24. Common denominator would be 24. 8/24 plus 1/24. That's going to be 9/24, which will be able to be reduced. You can divide them both by 3. So we're looking at 3/8, again, this is plus, 3/8 x to the 4th. And that represents the first 3 non-zero terms of the Maclaurin series for f of x. All right, that's a win right there. That's 8b. One more part to go. And here it is, 8c. Now notice I've changed the formula here in 8c. I don't want to confuse anybody. 8b, it was cosine squared plus cosine. In 8c, it's cosine squared plus sine. Okay, so a little different there. I've graphed the fourth derivative of this thing. Wonderful. P sub 3 of x is the third degree Taylor polynomial. Okay, we know what that means. Using the information from the graph, show that the error, hopefully that's what you're recognizing this as. This is the error. It's the maximum error. The error has to stay less than 1/750th. 1 over 750. The reason that that left side is the error is, again, this is the perfect answer of f of 1/4. This is us estimating the answer using a third degree Taylor polynomial. The difference between the true answer and the estimate is the error. All right, let's form what f of x is. Cosine squared, and I've already figured that out twice. I can copy that down, at least the first 3 terms of it. And then sine of x, we ought to know. That's a memorized formula. So when we add them together to make f of x, we get this. I'm going to start with the smallest power. So 1 plus this x minus x squared. I think I'll just cross them off as I use them. Cross them off lightly in case I goof it up and I need to see it again. Minus 1/6, because that's 3 factorial, x to the 3rd. All right, so that's done. Plus 1/3 x to the 4th. Let's see, plus 1/20th x to the 5th. And so forth and so on. Hopefully we're not going to need anything else. That will go on forever. So that's f of x. Now we want to plug in a 1/4 because the 1/4 is referenced in the problem right here. And we want the error to be less than 1/750th. All right, so let's see what we have. All right, I have to admit, I got a little carried away with that last term, that 1/120th x to the 5th. That wasn't really necessary. And the reason why is because in the directions, which it's always important to read directions, they mention the third degree Taylor polynomial. So that chops this off here. And they mention it again right here, third degree, evaluated at 1/4. So this 1/3 x to the 4th becomes the first neglected term. And so the error has to be less than or equal to that first neglected term. Let's go ahead and take that 1/3 x to the 4th, and we'll plug a 1/4 in. Again, we're plugging into 1/4 because it's the number that's mentioned here in the absolute value. All right, so the error has to be less than or equal to the first neglected term, which is 1/3, times 1/4 to the 4th. The 1/4 goes inside. 1/3 is here. 1/4 to the fourth is 1 over 256. And you can see that 1/3 times 250 would have been 750. 1/3 times 256 is actually 1 over 768. And so if the error is less than or equal to 1 768, it's certainly going to be less than 1 750th. So we proved what we needed to. At this point, a fair question might be, well, what the heck's up with the graph that you made? It's taken up all that space and was part of what we had been talking about earlier. You never touched it. And that's a completely fair point to make. So let me show you another way to do this. I sort of inadvertently made a problem that can be solved two different ways, and normally that's not the case in most examples. So let me kind of re-explain this and work the graph into it as well. Here goes. Our alternate explanation, again, this is still the error here, would be to say, hey, you know what? If we're doing the third degree Taylor polynomial, then the fourth degree term is still the first neglected term. Here's the fourth degree term. It is the fourth derivative. Remember, that's how we notate that. Times x to the fourth over 4 factorial. Of course, x is going to be 1/4 because, again, that's what the problem has called for, and that's what I used in my other explanation. But remember that we want to go ahead and make this as large as possible. We want to maximize it. Because if you maximize the error, then you're safe. We want to show that this entire thing here has to stay less than 1 750th. All right. Here it goes. 1/4 to the fourth is still going to be 1 over 256. 4 factorial is 24. We want to maximize the fourth derivative, however, and remember that x is 1/4. I forgot to put the 1/4 in that first one. So what is the fourth derivative at 1/4? Well, we have a graph of the fourth derivative, as luck would have it. And you can see that since this is 2, this will be 1 right here. This is 1/2. Here's 1/4 right here. And so as I head up to 1/4, it's hard to tell where I'm crossing. Maybe right around 7.5 or so. Maybe it's 7.6. I don't know if it's below 7.5, but clearly it's below 8. That I'm sure of. So if I make this green circle into an 8, then I am absolutely safe in my assumption. So that's what I'm going to do. And of course, the 8 and the 24 will cancel into a 1 and 3. So we have 1/3 times 1 256. That's exactly what I just had on the previous page before I erased. That's going to be 1 over 768. And if the error has to be less than 1 768, then certainly it's going to be less than 1 over 750. So again, there's just another way to show it. And that's it for today's lesson. Day 3 is done. That's all I've got. Good job, everybody.